Okay, so I'm going to open up what we have done last time, quickly go through it as a review, and then we'll continue afterwards. So going back to notes over here. I'm not going to go through recursion. We don't need it. All right. So we talked about the trailing return type in functions. Is it big enough back there? Or you want me to make it larger? People at the end row. Are we good?
Yeah.
A little bigger? Better? Okay. All right. So we talked about trailing types, and we said you can actually have your functions now by auto and the return type being at the end. Why that was the case? Because we said sometimes when you're actually writing a program, the compiler needs to know what the return type is after the fact, so it can actually change the type based on what the compilation is. And because of that fact, we put the return type at the end. And I gave you an example for a template for an add. So this cannot be set on what the return type is unless I know what A and B types are. So I cannot write the return type before add. I have to find out what it is based on T and U, and the declared type over there will actually determine that one. And therefore, the only way that this can work is to have trailing return types. Then we talked about having return types, trailing return types used to shorten the code instead of actually writing something like ticket, scope resolution, ticket type, yada yada, all the stuff that we have. I can simply write auto and I write ticket type, because when it's after the name of the function, it comes into the scope of the class. Therefore, it can recognize what this inner class's type is, and I do not need to qualify it. We talked about external linkage, and we said external linkages with functions and methods are exactly the same. When you create, functions and variables are exactly the same. When you create, I had a module over there too that I have to open it up so you can see.
Like a promise that would be made somewhere else.
Yeah, exactly. So when you actually, for a function to be prevented to be externalized, you can set it as static or any variable. So this static internal that you see is only available in here. And same thing as display. Display and internal, they cannot be externalized. They cannot be globalized. But if you have a regular function and a regular variable, the variable can be set to a true global variable using extern, and the function can be externalized, globalized using a prototype. That's why we have prototypes in the functions, in a header files. Essentially, you make a function available in other scopes by adding a prototype. We can do the exact same thing for the variables and objects using extern. And I mentioned that the cout that you're using is actually being externed in IOStream. That's why you have access to it. It's a global object created out of OStream. And it's externed in IOStream. Any place you include IOStream, you can use cout, because now it's defined. And that was externals. Then we talked about the need of being able to pass logic around as we did with the address of the variables. And we said when you create something like a foolproof data entry, the validation that you want to do for your data entry may be different depending on what the data is. In here we had a getInt. GetInt was doing a foolproof entry, but when it was reaching to the point to see if this integer that is a valid integer is actually a valid data, I need to have specific business logic check over here. For example, if I want it to be an adult, I have to check if the integer is adult, and then it's good. And we have a function over here for that. If I want this to be number of students, then I had to replace the function with the new function, recompile my code, which is awful. Because of that, we said C language, and it has nothing to do with C++. C language has the capability to hold the address of variables, of functions, hold the address of functions in what we call a function pointer. So if you have a function with a specific signature, you can simply copy the signature in your code. So I have void int int. I'm going to write void int int. Where you place the name of the function, you're going to put a name of a pointer. And not to get confused by a signature, by a prototype for a function, you put the entire name and the asterisk that makes that a pointer together inside parentheses. Therefore, funcPTR is no more a function, but a simple pointer, one variable pointer that can hold the address of any function carrying the same signature. And where the function's address resides, inside the function name. From here, we can find out and understand that the parentheses that you put inside the name of the function to call it is nothing but an operator. So if you want to gain access, so if I have something like this in here, if I have something like integer value, and I write over here address of val, if you write something like this, to actually go to the target of x and get the value through x, you use the target of operator, correct? You would say something like target of x is equal to 1, 2, 3, and therefore val will be set to 1, 2, 3, correct? Now, when you have a function add, if you just write add over here, you're referring to an address. To tell to CPU to jump to that address and execute, that's the function call operator. What is a function call operator? Parentheses. So essentially, when you put parentheses instead of in front of anything, it wants to call it. Look, if I put x over here like this, it wants to call it. But if you compile this code, it's going to tell you, hey, that's not logic. That's something that cannot be called. It's not a callable address, and it's going to stop you. To actually call a function properly, you have to put the address of the function. Then you have to pass the arguments the function requires, and that's what that operator does, the parentheses operator, the function call operator. Therefore, 10 plus 2 will be doing this. That was a question, or you wanted to say hello?
Well,
Okay.
but I was going to ask, so I understand that the brackets are an operator unique to functions.
I'm going to call it parentheses because brackets can be 50 different things. Okay?
Okay.
Okay.
I was just wondering, are there any other unique operators that we should maybe be aware of?
As we go forward, you'll see, and you keep getting surprised. Wait for it. I cannot
You
give.
gotta keep us
Okay,
on
yeah,
our toes.
yeah. So essentially, as we found out that square brackets are nothing but operators, when you put it in front of an address, it adds to that address so it can simulate an array. Parentheses are operators you put in front of an address of a logic, and it jumps the CPU to that place to execute it. That's why I can actually have something like void funcPTR. So this is only a pointer to any logic accepting 2 ints and returning nothing. So any logic that does that, it doesn't matter what. Any logic that does that can be called. Now in here I'm doing add, multiply, reduction stuff. I can write over here void, and in here I'm going to say integer value and an integer repeat. And I can say over here for I equals 0, I less than repeat, and I plus plus. And I can say cout val with a space after. Whatever. It has nothing to do with addition, right? But it will work. Because it's a function. Oh, it needs a name too.
It needs a name.
Yeah. Rep. Okay? So the rep function can be held in funcPTR. There's no problem with that. We can do it actually. Okay? So because I changed this code, let me actually copy it and put it in the current one so I can actually run it for you. Oh, let me just, yeah. So it's going to be this now. And okay. Yeah, let me just close the other one without saving. So now, now we can see I can do add, or I can say funcPTR rep equals to rep. And I'm going to say funcPTR 1040. 4010, sorry. 1040 would have been interesting. Anyways, right? So it looks like they're the same, but the first one's going to add and the other one's going to do that. And because the function call is mentioned over there, let's remove this. So when it, which one was it? There we go. So when it actually runs like this, what happens is that 3 years later when it compiles, let me bring it over here so you can see what's going on. That would be nice.
I'm not sure what would happen.
Okay?
I got a good hypothetical for you later.
So it comes over here, it shows the thing. We don't care about those things. Now, funcPTR is some garbage, but as soon as you pass through it, now it becomes the address of add int in February 6 executable. And the function call means jump to it. So it runs the add. Now it comes down. This time I'm going to say funcPTR is rep. Now it becomes the address of rep. And when I call it, it repeats 10 times. We got it? You understand what function to pointers? Function to pointers. Pointer to functions are. Okay. So a funcPTR review. So we learned function to pointers. Yes, sir.
I've got an interesting hypothetical. I was just wondering what would happen if you were to reassign a pointed function within a function. Would it?
Doesn't matter. It's a variable. Don't confuse yourself. It's a variable. It's just a pointer.
I'm just thinking almost like a chain or recursive with changing functions.
Sure, you can create a pointer in a function and another pointer in a function. Doesn't matter. It's just a pointer. Nothing cascading is happening. You're simply creating a pointer to a function and you're setting it to a logic.
The function, you'll be fine.
Doesn't make any difference. It's just a pointer. Okay? It doesn't matter if I create a pointer where. It's a pointer. Okay? So going back to the foolproof entry of ours, I would say instead of just calling valid over here, is adult over here, as an argument, I can receive a function of a pointer to any function that accepts an integer, validates it, and returns a Boolean. And because that's the signature of is adult and valid, it doesn't make any difference to me. I can call the getInt passing is adult to it. Now it's going to validate using is adult. And I can do getInt. Now it can validate using getInt because the signatures are identical. So different functions are going to get called in here. We good? Now, just a note, if you do this in C language does it like this. In C language, you have to call it like this. C syntax for function call with a pointer. C++ fixed it. C++ said they're all pointers.
Sorry, is valid as a keyword?
It's not a keyword. You want me to make it hoo-hoo again?
No, that's fine.
Or make it hee-haw? Whatever. It's a pointer. Is valid. I called it is valid because it is supposed to point to a function that does validation, receiving an integer and returning a Boolean. And it will be replaced by whatever it is. In this case, it's going to be replaced by is adult. So running it I can't run it because it's on the other project. But you get the message, right?
Yeah, I get it.
Now what we have over here is pretty cool and straightforward, but let me put this thing away, bring this thing down for a second. Where is my schmiggly dingy? Now here. Where did I put it? Just a second.
So if you had multiple functions with the same input-output and you have a pointer you have to assign it, it would be unique to it.
Yeah, obviously. So going back to what we talked about, I'm going to do this. If I have a pointer to a function, if pointer to a function is really a pointer to a function, then, and say these are my functions. Sorry, I changed the names. That's my cheat sheet. I'm bringing it in. So these are the functions that I have: add, subtract, multiply, and divide. Okay? There is nothing preventing me in creating an array of pointers. We learned that in OOP345, right? So now you see that void func4. Now I have 4 pointer to function of type of receiving 2 integers and a void, and I am initializing it with add, subtract, multiplication, and division. So now in this for loop, I am using the function pointer array element, calling different functions in a loop. So I can go through it one by one. So in the same loop, I can call 4 different things. So essentially it happens like this. Take a look. It comes through this, prints that. Now, if you look at these, the first one is add, the second one is subtract, the third one is multiply, the fourth one is division. And therefore, the first one is add, the second one is subtract, multiplication, and division. I'm calling the different functions with their address pointer.
Just got to remember the order. Just got to remember the order.
Nah, I'm giving you an example. Anything's possible. I just want to put emphasis on it that It's just a pointer. Don't give it extra credit. The job of this pointer is to hold the address of a logic. The job of pointers is to point to stuff, right? This is pointing to the logic, and the logic must have that signature. And that's it. And it's a good thing for a walkthrough. Now, the validation thingy that we had, if you recall the validation thingy that we had, where is the validation? Did I put it somewhere? Was it this one? No. So let me actually bring the code. I'm going to bring the code. So see what I'm going to do? I'm going to make that foolproof validation better. Take a look at this. See what I'm doing? I'm saying a validation function is not a function for an integer, is not a function that receives only an integer and returning a Boolean. It also receives reference of an error message. So if I'm writing is adult and I am testing the integer, if that test fails, I'm going to set the error message to the proper value. And it's a good idea, actually. I just noticed that this has a bug. First, I'm going to blank the thing. Error is nothing. So I'm just going to blank it out, and this one too. So before it actually wants to check for the error, it cleans up the error. Then it says, if it's troublesome, set the error message to the proper error message. Now the validation not only does that, but also sets the error message. Using this, I can actually change the type of my getInt function to something that makes more sense, which is essentially sorry. I did the wrong thing. There you go. I wanted to copy, I pasted, yeah. So if I write something like this, so now I'm saying my getInt receives a function for validation that receives an integer and a reference to a string. So I changed the signature. Now anybody who wants to use my foolproof data entry, they need to have the proper validation. Have the proper validation and know how to copy a code. I'm very bad at this. Okay. All right, this is much better. Okay. So I'm going to say enter age, I'm going to pass is adult, and I'm going to say age is that, enter number of students, and yada, yada. So now my is adult and valid number of students will set an error message, and the improved getInt function will look like this, which is essentially it's going to have an error message that is blank. Then if it fails generally, it's going to say the integer is bad, try again. Then it makes sure there is nothing after. If everything is good, then it checks with an error message. If validation is good, I have no error messages that come out. Otherwise, it's going to show the error message, the validation is checking. Therefore, I'm going to have a clean and understandable validation happening. So if somebody's asking for age and I do this, that's invalid integer. But if I put 5,000, that's no children or seniors. It means that's wrong thing. Anyways, we should have said it. I could have set that validation to be better. So your validation can go through it. If it's less than 10, you can say no children. If it's greater than thing, less than 110, no seniors. If it's more than 110, say this age doesn't exist, whatever. So that's that anyways. So now we'll put over here 35, it works. Now number of students, again, that's invalid integer. And if I put over here 3,000, invalid number of students. But when it's 20, now I'm good and 20 students in class. So as you see, you can actually write your little validation function and you pass that one to the complicated function that does the data entry, so it uses your logic to do the proper thing. Are we okay? All right. I'm sorry math is gone because it's a turning point in C++ now. Something that is new and it's extremely important to know, okay? So now we are going to see what callable objects are. You guys are in my class? What the heck are you doing? Anyways, I don't know. Anyways, so we just mentioned that the parentheses are operators, right? So let me do something like this. I'm going to say so I'm going to say class add. I have a class whose job is to add stuff, okay? And I want to know how many times the addition is being happening. So in here I'm going to say size t, number of calls, public. So what I'm going to do, I don't need a constructor in here. I'm just going to public. Okay. Now, what I'm going to do, I'm going to write over here int do add, and I'm going to pass over here integer num1 and integer num2, correct? Right? And in here, first I'm going to say m number of calls plus plus, and then I'm going to say return num1 plus num2. Obviously, I'm going to have a query over here that says int number of calls const, and that returns m number of calls. We good? Right? So now I can actually create something like this. Add, right? Now I'm going to have something like this, say integer a, say set to 10, and I'm going to say integer result, and I'm going to say result is add dot do add a and 50. Are we okay with this? Right? And I can go see out. Okay, now What's good about this? What's good about this is that if I wanted this thing to be the validation function that I had, I don't need to have an address anymore. I can simply pass the class as reference. It's like and I can do add thingy whatever I want. So the action that it does, it's actually carrying it around, right? It would have been nice if I could actually make this thing look like a function, so I don't need to write do add. I wish I could do this. Then it looked like a function, right? The answer is, of course you can. Done. So now what I have is called a function object, or a functor. You don't need, so you don't need to have pointer to functions anymore. If you want validation to be done, create a class for it. The good thing is that you can actually have stuff in here. Like if I wanted to do validation, let's say one of the validation is do password entry. And I want to keep to do the validation. I want to count how many times it's being done. I can't do that in a function. Here, I can have state being added to it. I can have properties. I can do stuff in here. It becomes a stateful function call. So these function objects make your life much easier. You can actually pass them around and do all the good things that you want to do. Yeah, so now I can actually do this. So if I actually have for and I plus plus, and I did this 20 times, now I can say cout add dot number of calls, because it is an object. All right?
You have an object function.
Object function. It's literally called object functions. Okay? Functors.
That's still a ridiculous name.
Makes your life, and you will see, we're going to do amazing stuff with it. It's going to make your life beautiful.
So the operator,
So
regular operators have stuff inside the first. No, they don't.
now, and if you want this add thingy to work for different things, you can keep going. You can make it a template if you want to. Doesn't make any difference. Remember, we wrote an add with a template. You can make this it's a class. Make it a template. Make this type 1, type 2, and do a declare thingy like we did with the other one. And it's a functor template. It does everything for you. Okay, it's a beautiful thing. We good? Okay.
That's phenomenal.
Okay, so that's functors. So I'm going to say functor intro. So the validation thing we have written now can change to something like this. So instead of having I want to have my then I can have something like this. Take a look at it. If I want validation to be done, what do? I create a class, and I call it int validation. And I'm going to say it has a protected value that is number of validations, because I don't want to get the thing I wanted to. Anyways, you can see that. And then I'm going to create a public virtual Boolean operator int val string error message equals to 0, which means this is an interface. This is an abstract-based class. and I'm going to pass that int val reference to valid. Now, anybody who wants to use my validation is forced to inherit a concrete class out of this, implement the validation, and they're done. Actually, let's make that number, let's have that number of calls over there. I don't like it when I made it protected. Int, actually I can do this. I can say operator, let's make that size t. Nah, forget it. Forget it. Anyways, let it be. So now, if anybody wants to use this, they have to inherit that class. So for example, I would say class age, valid age, inherited publicly from int validation. And in here, I would say public, and I want to public, and I want to overload this. Override, my apologies. Override this. So I'm going to do it like this, and I'm going to say bool result should be optimistic or pessimistic. We'll find out later. I'm just going to do it like this. So I'm going to say if val is less than, no, I'm going to call it not valid age. I'm going to say is teen. Okay? So I'm going to say less than, if it's less than 12, 13. If it's less than 13, or if val is greater than 19, 20, 19, then I'm going to say error message, only teenagers, please. Something like that. And else result is true, right? And return res. Now, if I want to get the valid int for a teenager, I can simply go to my main, int main, and I can say int age, cout age, and I can say age is equal to, what was the name, get int, and in here I'm going to say, what is the name of the, is teen, right? I'm going to say is teen. Create a nameless object out of it and pass it through. Is teen publicly, yada, 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 yada. Class is teen. Why is it giving me an error? Oh. What do I have over here? Oh, it's a reference. That's why. It's a reference. So I have to create his teen. So I'll go is teen. And because it's why am I passing a reference? I don't know. But anyways, so in here I'm going to go is teen. And that's it. Done. Because the teen is doing the validation like that, it is a child of is integer validation, comes over here. So when valid's call operator is invoked, it comes over here, and because it's virtual, it jumps to the latest version, which is this one, and teenager is validated. We good?
You made a polymorphic reference function rather than making a pointer for a polymorphic handler.
If I didn't have a reference over here, I could just put a temporarily expiring value in here. But I didn't. Anyways, that was the case. And Anyways, so that's going to get you the age for the teenager. Okay? So this is get int functor version. We good? Are we okay? And please, 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 please remember, everything can be a template. It doesn't matter what you have, you can have a template out of it. So I can have a template for ascending, descending, whatever I have over here, and then I can literally pass pointer to function. So look at this sort function, sort that I have. It's a template. It receives address of a templated function that receives two types and compares the two. My functions are ascending and descending, as you see in here. So, and the display is a templated display. Sort is a bubble sort that is using that comparison to compare the two items. So in here, when I say sort A, which is an integer, and an ascending int, I specialize my function. Therefore, it's going to be address of a function that gets generated for ascending. And it's going to compare into ascending and descending. So you can create templates for pointer to functions too. It doesn't make any difference. Pointers, templates are just things that are created by the compiler. And because I'm not calling it, I want to have just the name. As soon as you specialize it, compiler sees that ascending is being used, therefore it generates its code, therefore it has an address, therefore it can be used by sort. Okay? Questions on this?
I'm confused. Do you want us to become?
Okay. If it was just a function called ascending, I'm going to put it like this.
Yeah.
If it was just a function called ascending, not a template, and I had a so let's say, let me do this. If this was just an int and an int, and this was a sort of an integer array, and this was receiving a function with two ints, you had any problem with it? No, it would use the same. And I could simply pass the ascending over here because it existed, it did whatever, right? Templates are literally functions that I'm requesting operating, that the compiler for me to write it. So all I'm doing in here, I'm saying my templates that is sorting use a comparison for two different types because I want the sort to be able to sort employees, I want it to be sort anything, right? So I want to pass a logic that can change based on what is being compared. So I'm going to say, don't receive a function with a template, but receive a pointer to a function with a template. So essentially it says, I'm going to receive an address. So if you are calling the sort with a double, it's going to look for a pointer to a function that has two doubles. When you are calling the sort for a car pointer, it receives a comparison function for two cars. Are we clear on that? Now, when you have the function over here that receives the two types, how can you make that get created using the compiler? Either you have to call it, or you have to manually ask for its creation. To call to, if I have over here, if I say over here, comp, or compare, what happens over here? Oh, sorry, not compare. What is the thing? Ascending it was? Ascending. If I do like this, what's going to happen? It's going to generate an ascending function for me that accepts two doubles, correct? And therefore, ascending over here will have an address that I can extract, correct? Now, if I don't want to call it, what do? I add it as if it's specialization. So I'm telling, hey, compiler, I need a function for ascending done for integers. Compiler will create it. And as soon as it creates it, the address materializes and gets passed to the function. So this essentially will cause generation of a function of type integer and passes it through. Yes?
So template creates on call rather than just automating everything.
The function templates do.
Yeah.
Class templates don't. Class templates must get generated using their signature, right?
Yeah.
Hence, the same thing over here.
Okay, I was just wondering if they stay local like variables, would they die at the end of the function they're created or called from?
No, when the function is created, the function dies when the execution ends.
Okay, so it stays in memory.
Yes, it stays in memory, yeah.
It's an active.
Yeah. Anyway, so that's that. So this is for function pointer templates.
Be a weird way of protecting functions.
Yeah. And now, this is the same sort that we had, but using functors. So essentially, I'm going to create a enumerator class for ascending and descending, and I'm having a compare class that accepts an order which is of type ascending or descending. Then I will create the compare class using ascending and descending, and then I'm going to say the call operator for the two integers that are being compiled, because it's supposed to compare two integers, will, based on order, if it's ascending, becomes greater than, otherwise becomes less than. Therefore, this functor, based on how it's created, it will go ascending and descending for integer values. It's your job at home to convert this to a template so it works for any type. Okay? So now I'm saying sort receives a constant compare functor and calls the comparison over there. Now in here, all I need to do is to say sort A using n and create a temporary nameless ascending compare. It goes in and does an ascending. And now create a temporary nameless descending. It goes in there and does the descending. So that becomes the functor version of the sorting. Instead of passing the address, I'm passing the object. So therefore, there is no need for function pointers. So functors are the answer, the object-oriented answer to a function pointer in C, done in C++. So in here, I'm going to say to do. Didn't I do it? No, I didn't. Good. To do. Make the class compare a template. By the way, I may give you that as a question for your midterm. It's a very valid question. Give you something like this and say convert it to a template. Compare the sort to a template, compare everything to a template. Easy breezy. And also, actually, I have a better idea. compare this class compare to an abstract base class that is a template. So anybody who wants to, and then you sort with that one, that's actually going to make your life easier. You sort with that one. Whoever wants to sort, they have to inherit that template into a concrete compare class that compares whatever they want to compare, and they can feed it to sort, and it would work. So this has to be a template, and this has to be a template. And if you have trouble with it, please put it in your repository, then you can contact me, I'll help you with it. Now, sometimes functions are so small that you don't want to write it. You just want to have a little function to be done here and use it once and be done with it. Remember the getInt that we had? That received the valid int thingy? Seriously, I have to write an add function over there for like compare function, like a one-liner function for a condition to pass to the damn thing? I just want to write a small little piece of code and make it a temporary function and be done with it. Can I? The answer is yes, you can. So if I want to see if this is a valid mark, what do I write? I write over here int, bool, right? Valid mark, correct? And then I'm going to pass over here an integer that is mark. Are we good with this? And in here I'm going to say return mark being greater than or equal to 0 and mark being less than or equal to 100. Are we all good with this? Are you okay with this? See what I'm going to do. I'll take this thing over here, just make it small little thing like this. Right? We good down to this point? And then in here, I'm going to take that bool thingy out. I'm going to make it out too. Now this valid mark of mine will be equal to a lambda expression. So this valid mark now is a small little cutesy function that, by the way, I'm not mentioning what the return value is because it's returning Boolean, right? If you wanted to make sure it's Boolean, you know how to do it, right? I don't have to tell you, you know that. So now, this valid mark of mine is a small little function that receives an integer and returns a Boolean. And I can call it in my getInt. I can actually say over here,
so those are square brackets?
yeah, I can say int mark is equal to get int, and in here I can say valid mark.
You said this was a lambda? I haven't seen a lambda like this one.
Okay? So what's going on here? Why is it giving me an error? Because I didn't put this in here. There we go. What's going on? Get int is undefined. Oh, it's all. My apologies. Okay. Are we good down to this point? Are we okay? So I can actually write it like this, and it will receive. So in here, I'm going to say see out your mark. Okay, and in here I'm going to say see out oh, come on, Farlad, you can do it. Enter a mark. Okay, so I run this. It will call that function. And in here I do this. It's going to say invalid unreadable integer. Now I'm going to put over here 400. It's going to say try again. What did I write over there?
It's in the else.
See out. Bad, invalid. Try again. I think that's better. Anyways, invalid, try again. Now I'm going to put over here 40, and it says mark is 40. Are we good down to this point? Okay. Now, let's say I want to do something with number of students, right? So in here I'm going to say see out, enter number So what I want to do now, I'm going to say int number of students equals to get int. I'm not going to bother going over there and create another one. I'm just going to say int number STNO, number of students, that returns a Boolean, and it will return STNO. Let's say a student number of students should be more than 5 to have a class, greater or equal 5, and student number of students to be less than or equal 40. Semicolon. And be done with it. So why write a function when it's small enough for you to do something? You can do it over there. Just put the function inside the thing and be done with it. And this bool is redundant because it is returning bool. It is Boolean. You don't need to mention it. I'm just mentioning it. If you are returning a Boolean and that wanted to be casted to an integer, then you write int over here. Otherwise, this will do. So this literally will do the same thing as the other one. So see how.
All right, that was dumb. Do those lambda functions stay in memory like other functions, or no?
No, they are. This does, but that's the beautiful thing about it. After it's done, it's a variable. It's a local variable. It vanishes and goes. So your code will be in stack, not in executable. You can even dynamically create it and delete it. Crazy nuts, crazy thing to do, but yeah. But anyways, we good? Are we okay down to this point? Okay, so now if I run this, it's going to run the exact same thing. Absolutely no difference. I can go through it and enter a mark. I'm going to So enter a mark, I'm going to enter 30, that's fine. Number of students, I'm going to put 400, invalid, like this, bad, and I'm going to put 20, and number of students 20. So it's actually working. Of course, you can write ginormous lambdas. Nobody's prevented you not to do that. You can actually have something like this written. This is the whole lambda, like a regular function. You can do it. There's no problem. Please. But I don't think it's a wise thing to do. If you have something big like that, make it a function. Don't clutter your code. Be clear? Are we good?
I got a question related to lambda.
Yes.
I've only encountered the arrow function style lambda. How does that measure up to this?
You're talking about this one?
No, like equals greater than.
What are you talking about? Line number, please.
No, you don't have one. I've encountered a different style of lambda, and I was just wondering about it.
This is lambda. There's no other style. This is what lambda is. That's how you make lambda. I'm going to go through all the details of it. Let me just save this. Or maybe I don't know what it is. So EFGH, lambda intro. Now lambda is not as easy as this. I'm going to give you lots of stuff, what you can do with the lambda. But just to have a quick look into future, why we are having lambda, take a look at this. Take a look at this. I am having a vector of integers. That's a proper way of creating an array. We're going to learn. It's STL after the break. Now I'm going to say sort. Sort is an algorithm that is written already. I'm going to say start from the beginning of the V to the end of the V, sort it like this, and that's the lambda. And voila, it's done. Now I'm going to say for integer inside V, go all through it and show it out. So that's how we're going to code after the break. Everything is like anything that you want to do, believe me, there is an STL for it. You just need to know how to use it. So after all, the reason I'm telling you, you need to learn templates. That's why. We have templates for any type of collection that you have that keeps that thing efficiently better than anything that you can write on your own. Algorithms. You can do sorting like this. You can even do sorting, say I want the sorting to be done in parallel. Do parallel processing for me. And look, anyways, this is just a look into future. We'll learn the same after the thing. What we learn to do, what we are going to do after midterm. So after midterm, our job will be to teach you how to use STL, Standard Template Library. So what is Lambda and how it works?
So if I may ask, by the way, my arrow style is native to a different language, but I thought it was close enough that it would be the same.
Sorry.
I was dealing with C# before.
Oh, C#, yes, I know that, yeah.
So that's the lambda for C++.
Very elegant language. That's one of my favorites. I
love C#.
I used to teach it for a long time in Seneca. Not
Really?
anymore.
What happened?
Nothing. I went back to my origins. All right. So what lambda is like this. Take a look. So you have a capture clause. That square brackets that you see actually means something. It doesn't only mean capture. It doesn't only mean lambda. So you put capture clause in it. And then you have a parameter list. What is the return type and the body of the lambda.
So what would be the capture clause?
Capture clause specifies which outside variables are available for lambda. So the body of the lambda is within your code, right? So when you are looking at this as a lambda, inside the body, what variables can be used? Can I use the mark in here? Can I use number of students in here? The variables that I create outside, are they accessible inside this? You can change that depending on what it is. So I'll show you exactly how. So the capture clause. If you don't put anything in it, it means the code inside lambda is isolated. It doesn't have access anything to it, anything from neighboring variables. If you put an assignment in there, it means all the variables outside of lambda in the scope that is coming in will become available by value, which means you can access them, you can change their values, but it's not going to affect what happens outside. So if you have a variable outside of lambda, you can use it inside. You can get its original value, change its value, do whatever you want to do with it, but after you're done, it's not accessible anymore. If you put just ampersand, it means all the variables outside are accessible by reference. You not only can access them, but if you change, the values outside will change. You can always specify what is accepted by what. If you, let's say if I have a variable out there as x, if you put x, it means x is captured by value, and if you put y, then it means y is captured by reference. So you can mention which variable is accessed how inside the lambda. And I give you like plenty of examples over here. So add I to A essentially accesses everything by reference, which means the I that I'm receiving in here, and I go A plus equal, A whatever is outside will get added to it. This subtract, it subtracts I by whatever, but it's not going to change anything outside because it doesn't have access to anything. Show A will have access everything by reference. Coincidentally, I'm not changing the value of A. If I changed it, the A would have changed. Okay? So I can say show A. Just go through it and you'll see. Now, I wrote simple lambdas over here, not only those that I have as variables. So I wrote a lambda like this. So I'm saying get everything by value, start from 0, go up to A, and show asterisk. So it will go through, but the I over here is completely different with the I you had over there. Two different things. Now I have reference over here. I do not need to initialize I because I is coming from outside. And because I had 5 in it, it starts from 5 and goes up to I, but adds 1 to I as it goes through. So the I outside inside the function that lambda is created in will change. Yes?
For the lambda without name,
Can you give me line number?
show before, after show A.
44?
No, 51. 51.
51, okay.
Yeah, there is no name for this lambda expiration, so how can you use it? Just use, so we cannot use it
Again.
again.
No, I'm just using it here.
Okay.
So it gets it just gets called at line 51 and it's done. I'm just creating. I just executed, yeah. It executes it and it's done. Yeah. Yeah, exactly. Exactly. And the same thing over here. So this one is accessing by reference. Now, obviously, if you set it, it won't execute it. You have to do it yourself. So over here, it is accessing I by reference, by A by value, but A by value. And this one is accessing A by value, I by reference. Here I'm saying access everything by reference except A. A will be by value. In here I'm saying accept everything by value except I will be by reference. And you can continue. I can do like this too. I can, if I had more stuff, I can say and keep going. So you can change, add stuff. And that's essentially lambda. That's why this week we have 2 sessions for lecture, because there are so many things that it's impossible to cover only in one thing. And I'm supposed to teach exceptions too. All right. Let's say, let me actually bring the, let me see where I have the cheat sheet for it. So say we have 5 minutes break, and then afterwards I'm going to teach exceptions, okay? 5 minutes. I'm going to find the code so I don't have to write it. I'm going to pause the recording. Please remind me to. Thank you. Thank you. Resume. Where's the other resume? It should be somewhere around here. We saved this, right? We saved this as.
I'm not sure.
I think we did lambda intro. Yeah, we did that. Okay. So, talking about abnormal exits. When you're writing a program, you can exit your program in 2 different ways. Okay, you can either abort or you can terminate. Okay. When you do abort, it sends a abort signal, which immediately stops the application with no cleanup. When you do terminate, you call terminate. Terminate, you don't call it. It's get called when exceptions happen that are not caught. Okay. So abort, no cleanup. Terminate if exception is not handled. Okay? Let me actually save it. This is like this, and there we go. EFGH, abnormal exits.
Oh wait, it's K.
Pardon me?
It's supposed to be K.
What happened?
Down there, it's supposed to be K. Because we're done with J.
Okay. It's supposed to be K. Okay. Thank you. Why did I put H? You're right. K. Thank you.
Even with my glasses, I cannot tell.
What's going on here? Didn't I just change it to K?
Supposed to put in like the file name field.
Well,
Anyways, I'm gonna do it one more time. So in here I'm gonna say K abnormal exits. And delete that one later. Okay? Thank you for letting me know. Okay? Now, we are playing a game. So I'm going to throw things from here, and each row is responsible to catch it. Okay?
suck at catching.
All right. So let's say I'm going to throw balls. Okay? I'm going to say the first row over here is going to capture anything that looks like a sphere. Okay? The second row is going to capture any ball that is passing through. The third row is going to catch volleyballs. The fourth one, soccer. And the last one's going to get a baseball. Okay? Now, if I throw a volleyball, who's going to catch it? No, because I put it incorrectly. I said anything sphere type, this one's going to catch it.
Yeah, everything should be caught by the sphere.
So nothing's going to go through, which means I did my catchers in the wrong order. So this is supposed to be baseball, and then, I don't know, soccer, volleyball, basketball, ball, anything sphere-like, okay? Or we can do, I don't know, baseball, football, volleyball, basketball, any type of ball, and at the end I'm going to say anything that you see that is coming, if it's not any other, catch it. So if I throw, I don't know, this one, they're going to catch it because this guy said, it's not a baseball. You follow? Okay. That's essentially called exception handling in C++. So what do? You run your application. Your application is running. If something exceptional happens, they're going to throw exceptions. Now, exception is a class. You can inherit it in different ways. Remember I told you volleyball, but they're all balls, right? Then volleyball is actually inherits specifications of a ball with specific things. And the basketball is different, and the baseball is different, and a golf ball is different, correct? It's the same thing. So in here, if I throw a read, like bad integer exception, I throw it. If the first one, it says like bad float exception. The other one says bad string exception. This one says bad integer exception. That person is going to catch and do it and deal with it. The problem is that I am out of the picture now, which means if your code says, for example, open database, read information, check social insurance number, add credit, save information, close database. Okay? If during social insurance number checking, I throw an exception, everything else will be ignored. There is no way to go back to them. That's why some companies hate exceptions and they don't allow you to use it at all. Others love it because they say it separates logic of the application and error handling from each other. When you see a program is written for exception handling, it's as if everything is going perfect. Open database, read records, update records, close database, end. There is no error handling here. Why? Because when one of them is in trouble, it throws an exception and it's caught down there. Okay? What is the basic syntax of exception handling? Exception handling works like this. Let me put it in here. You have a try statement, and you put the code that is supposed to throw an exception in there. Then you have series of catches that are supposed to get more generalized as it goes down. So the first one is the more specific, and it becomes more generalized, usually line number. So these types are all exceptions, by the way. So in a good design, type 1 and type 2 are children of type 3. And here, it means something went horribly wrong that I did not expect. That's the part that I'm saying when you see a brick is coming, catch it. Although we're supposed to throw only balls. Okay? So any code that throws an exception goes in here, and that's how it's written. Now, let me give you an example of exception handling. The problem is that you cannot give any good example of exception handling. Okay? Why? I'll explain. Look at my divide function. My divide function says, okay, I have an array of doubles. I have an integer I and an n and double divisor. What I will do if I is between this and that, I'm out of bounds. It is, then what is the divisor? If the divisor is equal to 0, throw it. I cannot divide anything by that. Other than that, divide the element I of the double to whatever. So it's doing something. But at different stage, it throws different things. Now I'm going to say do try, and I'm going to write this as if everything is good. So this is the index, this is the divisor, I'm getting all these things, I'm calling it, and I'm showing it, as if nothing can go wrong in divide. But, in fact, I'll go to the next part, and I'm going to do all the catches over here that I'm supposed to do. In here, I'm just doing 2, but hey, okay? So this catch must match the type you are throwing. If up there you are throwing a constant string array, you see that? Then what you are receiving over here is actually constant character pointer. So it's going to be caught over here and everything else down there. And you keep, so this is awful. You're not supposed to do something like this. Exceptions are supposed to be what you call them. An exception. Through logic of your program, if I actually want to ask for a mark, and the mark is not between 0 and 100, that's not an exception. That's just user being stupid. An exception is that you are looking for a strawberry, and somebody gives you a hammer. Not even food. That's an exception. When you want a strawberry, somebody gives you a banana, you're going to say, I didn't want a banana, please give me a strawberry. But if you say, I want a strawberry, somebody gives you a hammer, you say, what the heck, are you nuts? That's an exception. Exceptions are supposed to terminate the program giving you something to handle. And then you do proper handling in the catch, and you terminate the program, says, what the heck, fix the problem. So all these exceptions that I'm writing over here and you're running, they're just sample code, okay? To show you what the syntax is. Real exception should be treated as such, which is an exceptional thing happening, not just bad data. We good? All right. LM exception example. I have 4 minutes. Shoot. Anyways, we have different types of, we have standard exceptions that are in exception header file that you include exception. We have, let me just put them over here. So these are standard exceptions. Okay? Logic error, program mistakes, out of range, invalid argument, domain error, runtime error, range error, overflow error, underflow error, bad alloc for bad allocation, bad cast when dynamic cast fails, things like that. These are exceptions that system throws, and it's really bad. And they are all children of exception. So you can look for each, and at the end you look for an exception. Exception is actually an object, okay? And this is a good example for it.
I usually do exception message for the output.
So as you see, I'm including new, which means I don't want dynamic memory allocation to return 0 if something fails. I want it to throw an exception. So now if this thing goes wrong, then I'm going to have bad alloc happening. And if anything else is thrown that I don't know, I'm going to say standard exception, e dot what. What is a standard method of e. So if you are creating an exception, make sure you inherit it from exception, and you override what to show what went wrong with your exception. So if you are creating a custom exception, that's the one. We good? When you have a function that you know it's not supposed to throw an exception, you put no except at the end. You've seen it in move constructors and stuff like that, right? That move, if you say no exception, then essentially it helps the compiler optimize it. If it doesn't throw, the program terminates immediately. So this is what's going on. So that no except that you put over there is just to, that's why when you remove it, it still works. When you put it, you're just optimizing the compiler not to generate any code for the exception to be thrown. That's why you always mark move and stuff. We have normal exit. Normal exit is exit and at exit. So these are the things. At exit, essentially you put a function in it. It means you want a function to be called if exit happens. So normal exiting is something like this. So I can create a function called exit1, and if I exit, it will exit the program, terminate the program, and cleans up everything. And this is exit1 essentially means return 1 in the middle of the program, normally. If you say at exit, it means right before you exit, you want this function to get called. So essentially, it's a destructor for your main. If you want something to be done before main quits, you can make it at exit. Okay? So that's normal exit. I know it's 1:26 and everybody wants to run home, but I don't want to. Give me a second. So using all these, I created a series of classes called int. This int is supposed to be a smart integer. So the int that you see over here, int.h, this is the first one. So an int, it's a validated int that validates the int based on get and put. The first one is the crappy one, where you have a valid, and the valid that you have actually checks a validity. And it's a function, right? So this is not something that you can improve. So that's the bad one. The second one is done with function to pointer functions, like we have done in C. So essentially, your validation will be a valid that receives this and that. So people, when they create your int, they pass the validation function to that int, so that integer that they create can get and put values in it with validation. We good? Then I created another version for it. You have a class here? There's a class here afterwards? Yeah. Okay, so come in, sorry. Let's go, everyone. Thank you.